Hello guys, and welcome to the first lesson of the third chapter. In this chapter we will gonna build the crystal, and in this first lesson we will build the base form. Oh no, virus. So let's get the D window and let's just disable the origin pointer here. So let's build a geometry, black, round, and let's call this crystal. So let's dive inside and let's generate a simple box. So this box or this geometry at the beginning will determine in the future how the overall shape of the crystal will look like. So let's just give this a little bit, something like that, a little bit a longer crystal. And this is our base input mesh. So let's create a null here and let's call this base input PTS for points, because now we will make a VDB from polygons. Let's make it a density, let's make it a little bit higher resolution, and let's get a scatter here and let's scatter some points in there. So let's get 50 points for now, or let's get 30, so it's a little bit faster. So now we can press D, go to our geometry and make the point size a little bit bigger, so we see our points here. So we've got our points, let's lay this out here a little bit. And we want to scatter on the points. We can scatter different geometries, but for the first iteration we will gonna scatter a box. So let's get here a box again. Let's get and copy the point. And let's copy them on here. So that's just like the second chapter, the cube, but now we want some randomization in the rotation and in the scale again. So let's place down an attribute randomize. Let's type here p scale. Let's get a second one. And let's type in here n for the rotation, the normal. And let's type here rand p scale. Let's copy this and rand rotation. Let's color these in here. Let's move that down. And let's play here a little bit. So let's change this to custom ramp. Let's delete the inner one. And let's get this again to 0.25 maybe. And here, let's leave it like that. Let's just leave it like that. Let's play a little bit with the seed here. And let's play a little bit with the rotation. So min value is -1 and max value, so -360. Yeah, just get some value in here. And let's get a seed. And let's just change this box here, make it a little bit longer, so 0.51 and 0.5. So let's get a random seed in here. Something like that. Looks pretty good. And now we want to change the scale of each box a little bit. And we will use a for each loop with that. So let's place down a for each loop. Let's just color it a random color and connect it. Now we got 30 pieces. We can go down on each piece. So with the single pass function, let's just get on here and view one box. So now we gonna get a transform here. and we want to scale it just maybe like this, or like this, or like this. So the cool thing is, now we can get the loop iteration in here for the scale. But for now, let's get here the centroid function. So currently our pivot is somewhere up here, but we want to get it the centroid from the box. So let's type in here centroid, open brackets, close brackets, and 0, 0. Let's copy this and change it here to 0, 1 and 0, 2. And now we will get the centroid here. And now we can scale from the centroid. So now let's create a meta node here. And let's get the values in here. So guys, let's go further with that. We just placed the pivot here inside of the center of the box. And now we can scale it with this pivot. But we want to do, or we want to get a random value for each of these 30 blocks. So we created here the meta import node, and let's just do this here. So let's get this axis, right click, reference, scene data, let's go to the crystal, let's go to the meta, attributes, global, and iteration. And now we will get the iteration. The problem is, when we connect all, you will get something like this. Looks cool, but let's go down with this a little bit, because we will get on the iteration number 29, we will get a scale of 29, and that's a little bit too high, 29 for the scale. So let's fit this. So let's get a fit here. Let's do first a rand. So we will get a random value based on the iteration seed. So this is our seed. So now we will get a value between 0 and 1. But now let's fit this value. So let's type fit 0, 1. And brackets. We want to fit this whole thing. And we want to fit it between channel. Let's make a channel here min, and let's copy this channel, and let's make here, paste it again, and call it max, bracket again, and let's hit apply, and we will get an error. Why fit rand 1, 2, 3, 4, 1, 2, 1, 2. Okay, let's have a look here. Oh, okay. Fit 0, 1, rand, detail, okay, that's good. 1, 2, oh, okay. We just need this one here. Yes, okay, that's better. And now we will get another error. We will get bad parameter referent max and min, because we don't have these parameters. So let's create these parameters here. Let's get to edit parameter interface. So on this little option thing here, and edit parameter interface, and let's just get a float parameter here, so just type float. Let's get a float, let's get it all the way down, and let's label this min, and let's call it min scale, and let's copy and paste it, and let's call it max, and max scale. And now we've got those both parameters, they're both on 0, so let's dial them up here, 1 and 1. And let's get some distortion here. So 0.25 and 1.05, and we will get something like this. And the cool thing is we can just copy these parameters into all three, and we will get something like this. And the cool thing is now we can make it a little bit more random here. Let's use a seed here, so the rand times maybe 5. So we got a seed here, 5. And let's get this expression here too. Let's get it to, this one is 2. And this one is 865, 865, and let's hit accept. And you can get into this into this window here with Alt E. It's a pretty cool shortcut, and just don't get it here. Let's copy it again and let's use here seed 556. Now we got random seeds here, and let's scale them a little bit here. That's the cool thing. Maybe like so. So now we are back in the loop here. Let's just pick one little thing here, and we want to get a little bit of bevel here, so let's get a poly bevel. And we just want to bevel it a little bit. So let's don't use the chamfer, let's use the solid and get one division, and we will get this little crystal shape here. 0.05, I think that's enough. And for now, let's create some pieces inside of this. So let's get a null down here. Let's call it out hull. But we need the inside pieces, so let's call this out underscore inside maybe pieces, or inside detail, or let's call it interior detail. So let's create this. So we want to get here and transform, append an VDB from polygons, and let's get here a density 0.05 maybe, or 2.5. It's pretty fast in the computation. Yeah, that's enough. So let's get this tree here, copy it down, and let's get maybe 5 interior pieces for each little block. We don't need this. Let's connect it here. Now we get the points in here, that's cool. And now we need something to cut it. So let's get another input here. Let's get here this to fetch input, and we need the pieces to cut it, so let's place down a grid here, and the grid is a little bit too big here, so let's view the grid here. It's way too big, so let's change this to maybe 5 to 5, and let's get the rows and the columns at the same size, so 100 by 100. You can just drag and drop the parameter and choose sorry guys, relative channel reference, and it will reference the other channel. Let's get a mountain here. Let's get a little bit of distortion, so get away from this 0 offset. Let's change it a little bit here, pipe it in, and now we need a boolean intersect again, and we will read the set B. So this one here we need to get as a surface. So let's get this in here, and let's get the hull in here. So, and now we need a copy to points. Let's get this here, get this here, and this here. So let's get a look at this, and at the size of the... Yeah, let's make it a little bit smaller here. So let's get the overall size a little bit smaller to something like that. Yeah, let's get a little bit bigger. And now we will get the interior pieces. So pretty simple here. Let's lay this out a little bit. Something like that. And now we can merge them together, but before that we will create a group. So let's create a group here. Let's recompute the normals here. And let's call this, let's call this $OS for the operator string name. And let's call it the inner, or let's call it mat inner for material inner pieces. Lay this out a little bit, and let's append here a null with the out interior detail. This is our hull, and just for now let's get another input here, and let's get some detail on the hull here, because now it's pretty uniform and we want some imperfection. So let's copy this here again. Let's get here a polypath. So we will create an outline out of this. Let's get some scatter points here. So let's connect this on this, and just connect maybe 8 points. And now we can connect this input, but now it's empty. Let's just get here down to the normal size. And now let's get a sphere. And with this sphere we're gonna create some detail here. That's way too big. So let's get, let's get this input here. Let's change the piece scale a little bit here. Yeah, that's better. And we control it here a little bit with the uniform scale. So let's type 0.4. I think that's pretty good. Now let's append again a mountain here to get some detail. Let's change the frequency to maybe 6 or 5. I think that's pretty enough. And let's get away from the 0 offset. We can change this later a little bit and get here a smaller element size. And now we want to subtract it. So yeah, let's get a boolean. Let's get a geometry A, and we want to subtract geometry B. So A minus B, and B is this geometry. And now we will get these details here. Let's compute the normals here. And now we will get this detail. So let's disconnect this, let's get this copied, and let's call it out hull for the final hull. And let's make here group again. Let's get this group right in here, and let's call it mud hull. And let's finally merge them both together into the output, and let's run this output. Takes a little while. And we are finished. So we will end up with something like that. Just for now you can play with the scale here. The scale is a little bit too big, so let's get it down to maybe 0.2. Need to wait a little bit here. You can also make a compiled block. Oh, I don't think the poly bevel is multi-threaded. Let's just have a quick look after that. Okay, we need another seed. Let's change the seed here for now, and let's have a quick look. Press D, go to batches and make the non-compilable batch large, and yeah. It's not multi-threaded, but we can also deal with that poly bevel above and make it multi-threaded. But for now we will leave it like that. Let's just play with the seeds above here, and with the number, so 25, let's make not so much. Let's get here a seed in. So let's get just a seed for the iteration, so every time we run this we get a whole different seed. So let's get reference, the crystal tab, and let's wait a little bit. It needs to take a little bit of time here. And let's get the meta data, the iteration attribute. So let's re-enable the flag down there and let it run through the 25 pieces. And we are done. Looks like a mess. You need to change sometimes the seed because this may, that's way too big. So let's change this here. So these pieces are way too big here. Let's get here a smaller scale. So 0.05, yeah, that's pretty good in my opinion. And let's view the output flag again, and let's wait quick for the pieces to compute. Takes a little while. So you can skip forward some seconds if you don't want to wait with me. So, and the last piece here. And that don't looks alright, so let's fix here this problem quick. So let's get here through one. So why does this pass not work? Let's get a little bit of bug fixing here. It will create a polypath, copy the pieces and subtract them. I think the pieces are a little bit too small here. So let's get here bigger pieces and let's change the scale here. And let's also change the seed here. Yeah, that looks way better. So let's merge them together and have a look on the single pieces here. So one, okay. Just to have a quick look here. Piece number 8 looks alright. 9 looks alright. Let's just process the pieces again. Goes a little bit faster now. And that looks way better. Cool. So, that's for this lesson, the crystal. And I will see you in the next lesson, guys.